Hey everybody, it's Zach the Welder here, and I'm super excited to be bringing y'all this video. So while I was at Fabtech, I got to spend about an hour playing with the Miller Laser Welder, and I got to spend about an hour there with one of the engineers on that project. So this thing is cool. It is going to be a game changer in the industry. I don't say that lightly. It's not just another waveform. It's not just another, voodoo magic thing that we're doing with TIG or MIG. This is a completely different process. The skill it requires is next to nothing. So if you're in a production environment and you need to hire somebody, I mean, this thing is like running a hot glue gun, and you can turn out some really, really amazing work. And the speed at which it does it blows TIG right out of the water. This is going to be big. I hope you guys enjoy.
Handheld laser, and it's very, very different really from anything else that's has been out there. MIG, TIG, stick, it's just a really different process. So some of the differences, the beads are, first of all, you're going to notice the beads are a lot smaller. Because the main welding processes, they really rely on the reinforcement because they don't penetrate as deep. Like laser really digs. I mean, it really penetrates deep. So that's one of the main differences. Another one, it's a lot faster. If you compare it with like TIG, you're looking at what, 5, 6, 7 inches a minute or something like that. With this, we've got a set of 20, and very easily I can go to 40. So I mean, you can get some pretty high travel speeds. So yeah, a lot faster. The heat input is really small. And you'll notice, like on this sample here, like there's been a lot of welding done on this, like that whole front side there, the whole back side. And there's, I mean, very, very little distortion.
That is amazing. It's like I work with like thin stainless a lot, and I mean that.
Yeah. If you were to doing this with TIG, if you were to do, I mean, to turn this whole thing into a taco, it'd just be all over the place. So yeah, those are some of the main differences. But yeah, very, very fast, low heat input. There are some things about it that are a little bit different. Considerations, you want to make sure you have the correct PPE on. That's one of the things, the glasses are special glasses for laser. And that's one of the differences, like between us and some of the others that are out there, right? I mean, you got a laser in your hand, so you want to be cautious, and you want to make sure you're following the safety that you really need to be.
Makes sense. Yeah.
So yeah, but yeah, just using normal nitrogen. We're working on steel or at stainless right now, so just normal nitrogen. But if you're doing aluminum, then you're doing argon. We're like, the main welding processes, you've got like a mix of gas, or you can do straight CO2. But yeah, that's some of the differences.
Neat. So nitrogen, like just standard off the rack nitrogen, not like a high purity.
Yeah, you can just use like an industrial nitrogen. Okay. There's some people who are thinking, oh, you know what, laser. I mean, you're dealing with like clean parts, super like high-end stuff typically. Yeah. But yeah, I mean, you can certainly use a high purity nitrogen, but really for the most part, for the stuff we're doing here, obviously.
Yeah, I mean, those welds are gorgeous. If you're just using off the shelf, I mean, that's cheaper than argon. So.
Yeah. Cool. Yeah, it is. You use a little bit more gas because the flow is a little higher on laser, but yeah, it's the gas it's pretty economical.
Neat. Can we watch?
Heck yeah, that sounds good. Yeah, just make sure glasses.
Yeah, I got my glasses.
Make sure you have your glasses on, a welding hood, and then gloves as well. We'll get you all dudded up here.
Okay.
Make sure you're
all kitted up.
Yeah, there you go.
Much appreciated.
Yeah, as long as you have the sleeves on and you're covered up, that's good. Your jacket is
not an FR one because I don't splurge on those.
Really, the main thing, you want to make sure that you're just covered up.
I got just no exposed skin. That kind of thing.
You want to make sure that you're good and covered up. But yeah, yours is pretty thick. So yeah, you're good. Okay. It's about the same as our jackets we've got there. So
makes sense.
Yep.
Okay.
Cool. Well, let's do this. I am going to turn the air on.
Okay.
Don't need a whole lot of fume extraction, but you do want some. There's still some that comes off of it. So, but what we'll do here, I'll just grab these two parts first. We're gonna put like a little plaque together here. Now with normal welding processes, what you're typically gonna do when you tack, you'll get it like on the corners and stuff like that.
Yeah.
With laser, it works a little bit different. So we're not gonna use wire, but the laser will go through the parts into the base plate or into the bottom.
Okay.
So provided that you have your parameters set right, we're not gonna weld it to the block underneath. So, you going?
Yeah.
Okay.
Nice.
Yeah, provided that we've got the parameters right. I've had people that have had to grind, so that's one thing. But we are going to the machine. This is telling us the parameters that we're working on.
Okay.
This on A0 is tack, and there's a sheet that shows you what those parameters are. So, and then we're running 045 is our retract. So when we let go of the trigger, the wire is going to suck back, so you don't like bury it into the puddle. Okay. And welds in there. So that's one thing. And then 20 inches a minute. 650 watts is what we're working with as well. So.
Okay.
But I am going to suck the wire back here. Okay, there we go. That's what we need. And I'm going to hand this to you.
Okay.
And you're going to give this a shot. So there are 2 triggers. There's this one here. There we go. There's this trigger here.
Okay.
Which is going to be gas. You can hear the gas going,
yeah.
Obviously. So what you've got is this button right here. That's the go button. That's going to start the laser.
Mm-hmm.
However, it's not going to do it right now because you have to have continuity. It has to be touching the material.
Okay.
So if you look at this, you have a green light when you hit the gas button. Green light, green light, green light, and then when you have continuity, it's going to blink.
Okay.
Once that is blinking, that is the only time that trigger is going to work. And the main thing, like we were talking a little bit about before, the safety concern.
Yeah.
Right. Yeah. We've got all the safety stuff on. We are in a booth, and we're safe. We're good. So, but you want to make sure, obviously, the people around you are good too.
Not in any danger. Yeah.
So what I'll have you do, go ahead and grab that, hold that down. Once that starts blinking, then you can do it. I want you to take it, put it right there on the corners, and let's tack them together and make sure that is
like at a 90, or are you
no,
at a...
You want to have the handle. You want to have the handle at about level or the same plane as what you're welding.
Okay.
So, and that's, I mean, it does a couple different things. There are things in the torch that will sense, like if there is some kind of a reflection or something like that, it'll shut it off.
Gotcha.
So they're pretty intense safety features that,
Okay, so hood down, I assume?
Yep, hood down.
Okay, that's nice. It's not like super dark, so just push down in the corners and hit the button?
Yep, hold the button down until it stops itself.
Oh, so it's got a spot timer.
Yes, it does. Yeah, and then hit it over in that corner there.
Okay.
And then hit the other 2 corners too. Now you can see, if you take that and you pull away right after you're done, I'll show you why. Okay, there's a good example why you want to hold it there for just a little bit. You can actually see how pretty and silver that is? And then that one's a little bit duller.
Yeah.
Because you have the nitrogen going just for a little bit after.
Just like post-low on TIG.
Yeah, exactly.
Yeah. Okay.
Yeah, you don't want to pull away on TIG right away.
Yeah.
So, yeah. So what we're going to do here, we'll put our little fixture together. Okay, we're going to do that. And then that's got a little hole on there so you can hook it onto your lanyard if you want to.
Oh, funny, okay.
That's kind of our proof that you welded today type of deal. Okay. All right, cool. That's still going. That's still going then?
Let me double check. Yes.
It is good. Okay. So what we'll do here, while you're going, I'm just going to kind of do this, or you can do this.
Okay.
And then once you get it started and you get the weld going, pull out of there, get your hands away. Stuff I'd love to have a clamp there, but anymore. So
Gotcha. So now that's the spot as well. So it's just spotting to the.
no, this is not going to.
Okay.
So what we're going to do, we're going to go to a different program there,
Okay.
and we'll do this.
Oh, whoops.
So that was an example right there. See how it said error 21? Reason why it says error 21 is when you pulled off of there, rather than letting go of the trigger, the machine sensed that. It was like, whoa, stop.
Yeah.
So, and that's in an effort to, have any kind of an issue with, the laser going anywhere except where it is supposed to be.
That's
So, a lot of safety features.
Yeah, that's nice that you got employees like that.
Yeah.
You're not having some idiot write their name on the wall.
Exactly. Yeah, that's one of the things that's very different with ours. We don't want that. You know? Everyone leaves with fingers and toes and everything else. So, yeah. Okay, there you go. We'll actually get the wire out of there a little bit as well. Okay. Now you want that butt. So there is a red dot.
Okay.
Because the laser is about the diameter of a human hair. So it's really small.
Yeah.
You think about stick welding. Stick welding is, some people have a hard time hitting the joint with that.
Yeah, and then you
imagine a hair.
Yeah.
So what we have is, like on the part here, we have a wobble, and you can see that getting wider.
Oh, okay. Okay, so that's the lens moving, or that shows you your. Okay.
Yeah. Up inside the handle here, there's what's called a galvanometer. It's like a mirror, wiggling back and forth. So that is what that is doing right there. And it's just doing it very fast. If I were to take that and slow it down, I can take the wobble frequency down and I can take that up. You can actually see the difference there. That is what it's doing.
Okay.
Okay, so I like going right here at 0 and 0 is a good nominal number. So I just stay there most of the time. There are definitely some things you can do that, make the bead look like you almost walked a cup down it. Or,
that's cool.
It's pretty neat. So there you go.
Okay.
And then I just take it right like that, just to make sure that you don't have any kind of a space.
Okay.
But what you want to do is, there you go. And then just because there's a potential for reflection, you want to keep your hands away from there as much as possible on the back side of what you're doing.
Okay, makes sense.
Yep. So that go all the way in the corner. There you go. Yep, right in there. Put it in there now, because it's going to feed itself. If you feel it bouncing, it's because you're fighting it. So if you've done a little bit of welding, typically people who have not welded, usually will do. It's a little bit easier. I struggled with it. Like at first, I struggled with it.
Yeah, because you want to push that.
Well, and I'm hard-headed. I want to do my thing. I want to do my own thing. Dang it! I want to be able to control it. And this is different. So you just have to go with it. Let the wire take you.
Gotcha. Okay.
So, all right.
So gas on, hood down.
Yep. Handle about at flush with that. You want to have it at about that angle.
Okay.
And the only pressure that you're going to give is pushing into the joint just a little bit.
Okay, so push into the joint a little bit.
Yep. And once you get it going, just get your hands out of there.
Okay.
Yep.
Oh wow, that just pushes you along.
Yep.
I mean, that for an unskilled operator would just be...
You feel it jerking a little bit?
Yeah. Oh, I'm pushing too much.
Yep, you're fighting it just a little bit. There you go.
That is...
Isn't that wild?
Yeah, I mean, you don't need any skill. It's just like a glue gun. I mean, that's easier than MIG.
That's one thing. So there's multiple reasons why this is phenomenal.
Yeah.
One of them is that the amount of welders that are out there, that skill is kind of going away.
Yeah.
And so we need to do something to make it easier. That's one of the things we do with our other machines too. We have auto set.
Yeah.
Stuff like that. To pick the diameter wire, pick the thickness of material, because that skill level is kind of going away. The people who are really
actually know what they're doing.
Yeah. So we have to try to make it a little easier. This is one way we can do that, and obviously, I mean, you can see like applications that are typically TIG welded.
Yeah.
This being a very, very easy way of of doing those.
Yeah, I mean, there's no skill, and I mean, the amount of distortion there for, I mean, the first time ever even touching one of these. I mean, that you passivate that and you're good for like I work in the sanitary world. I mean, that
we'll clean it too. This will also clean. That'll blow you away.
Okay,
that's pretty cool.
Neat.
So let's do that.
Okay.
So we'll go ahead and put that back.
Okay.
And we have cleaning nozzles, and I want to check and see where they're at here. There we go. So that is the cleaning nozzle.
Okay.
Right?
Oh, so there's no optics, so that's just a tube with a guide.
Yeah.
Okay.
So here's an example. See that Air 21 or 21? Yeah, that's telling you kind of broke before, because what the machine is expecting is, okay, I let go of the trigger. It wants a conscious, that feedback, basically, your finger letting off that.
Yeah.
And so what you have to do is just hit the gas button and it'll clear that air. Just so you know, okay, hey, we're ready to go again. Yeah. All is well. So how you replace this right here rotates just a little bit. That comes off.
Okay.
And then that goes right on there, just like that. Okay? Just like that. Now you can clean up to 15 millimeters. That's a little much for what we're doing. So what I'll do, I'm gonna take this down.
Okay, so that's the width that it sweeps back and forth then.
Yes. Okay. Yeah, so I'm gonna take that down to 4 millimeter. So you can actually take like 15 millimeter and turn it down while you're cleaning, and you can see it just goes. But this is gonna be pretty close to about the width of that bead, okay? Go ahead, all you do is drag it across. What you're gonna see, you'll see kind of a white line going across.
Yeah.
Center that in the bead. Okay. Kind of center it in the bead and then come across it. And you're gonna go about the same speed as you just welded. Okay. You are obviously controlling the travel speed.
Okay, gas on, I'm assuming, first.
Yep.
Okay.
Okay, go ahead and go. And you can go even a little faster than that. And then stop in the middle. Oh, there you go. No, that's good right there. Stop right there, yeah. And then you can actually see the difference between it.
If I don't have to use a passivation machine, Wonder Gel, or polish that
a lot of times just gets rid of like the chemicals and stuff.
Yeah.
You have employees. Yeah. You have to handle that.
Yeah.
Now you have to dispose of it. And so it really can help with a lot of that. So yeah, you can see. I mean, it looks almost like a mirror. I mean, it is clean.
Yeah, I mean so you just passivate it. So like in the food world, you know, anytime you weld anything like that, you got to passivate it afterwards. You know, polish it. And like no nasty chemicals, and you don't even have to regrain it.
No. It is beautiful.
Amazing.
I mean, there you go. You can see it in the camera. I don't know how close you can get, but
I don't know. I just hope it turns out okay.
There you go.
Yeah, this is a really neat. I can't. Yeah, I really appreciate this.
Yeah, the base material and then the weld itself. I mean, it's shiny. So
yeah,
pretty wild.
Yeah, that is. It's exciting because it's a new process. I mean, it's a new technology it's not just a different waveform or...
Exactly. It's not a modification of what has already been there.
Yeah.
And that really is what welding has been.
Yeah.
And so, there's nothing wrong with that. I mean, because like you add a new pulse, it absolutely reduces heat input. I mean, if those things, they definitely have their place. But this is, with it being a completely new process, man.
That's exciting.
Yeah, it is.
And the lack of skill that's required there to have something that looks great. Yeah, that's nice.
Yeah. So, pretty wild.
Yeah.
It's fun to show people.
Yeah, yeah, that is really neat.
So I'm gonna just get this ready. Just take that off again.
How long is the cord there?
Put that on. So the cord is about 10 feet.
Okay.
10. I believe it's actually 12 feet.
Okay.
But that is for the cord width for the wire. Okay. And the reason why that is shorter than the gun, because the gun is 30 feet. The reason that's shorter than a gun is because with the wire going through, like if you're feeding aluminum, Aluminum goes through there like a noodle.
Okay.
And so you can't really, it's hard to feed aluminum through that liner. If you go longer,
Yeah, you have issues.
you have issues. That and the retract that we were using.
Oh, yeah.
If you have that longer wire, there's a little bit more slop in there, so the retract doesn't work as easy. So then you'll end up sticking in the puddle and doing some of that stuff. So.
I got you. So if say like if I'm using just strictly stainless steel, is there an option to go with a longer, like what would be cool is if I could set this next to a fab table and then just kind of work around it and not have to drag it hard. Is that something that you could do for a harder wire like stainless? Or?
Harder wire going, yeah, I mean in theory you could do that. The only issue you deal with is that retract. Because you're not with stainless, you're not dealing with the wet noodle going down the lead. Right? This doesn't, it has way more column strength than aluminum. So yeah, you could like really could do that. It's just that retract.
I got you.
So you can, it's longer because now I can clean 30 feet away.
Oh, okay, that makes sense.
Or I can weld without filler metal, because you can weld without filler metal or tack 30 feet away. So this is just for welding with filler metal. But most of the time when you're welding with this type of thing, you're going to be in a pretty
enclosed
like in a tighter space. Yeah.
Okay.
Enclosed space, or you're going to be having the machine fairly close to where you're at.
Gotcha.
So, yeah.
No, that's awesome. I really appreciate it.
Yeah, no problem, man. No problem.
Thank you very much.
Yeah.
Yeah, that's cool.
Isn't that wild, man?
Yeah, that is really wild.
You get a little bit of color. Some of that color came like when you were fighting it just a little bit. Yeah, you can get rid of that by just going right across. I think this one probably, you can see how that's a little bit more of a gold color. The bead is smaller. That's just from fighting it just a little bit there.
So you just need to kind of let it
Let it do its thing. Yeah.
That is super cool.
Which is hard for people who've welded a lot.
Yeah, that makes sense.
It's a totally different mindset. So
yeah, because you want to push, especially like if you do a lot of aluminum, you want to push into the puddle there rather than just letting it. So that's that's super cool.
Yep. But yeah, we'll let it sit there so it cools down a little bit so you can take it with you. But
neat.
Yeah.
Well,
yeah,
I really appreciate it.
Not a problem. Not a problem. What do we have over here? Another one there.
And that spot for sheet metal, that would be nice.
Yeah, it is.
Like
it is pretty incredible. Let me think about like plug welds and stuff like that. I mean, you don't have to drill a hole. You kind of don't have to have that process. It doesn't replace it totally. I mean, there are going to be times on real thick material that you're going to need to do a plug weld. You're going to have a hole. But for sheet metal applications, I've done that spot welding on a 1/4 inch.
Really? It goes through 1/4?
Yeah, it does. It will. So it's pretty incredible, but yeah, pretty neat.
Big thank you to this gentleman here from Miller. I'm not sure if he wants to be named, but thank you very much for the opportunity to play with this machine and to record. Thank you all for watching. Please tune in to the next video.